Hi, today we are going to see about PN sequence generation in digital communication techniques. What is PN sequence? PN sequence are codes that appear to be random in nature. They are generated using predetermined circuit connections using shift registers. They meet a number of randomness criteria. PN sequence are usually generated using linear feedback shift registers. The length of the PN sequence depends on the number of shift register stages. The maximum possible PN sequence length P is given as in below equation, where P equal to 2 power n minus 1. Such a sequence is referred to as a maximal length sequence. For example, in this figure, a 4-stage linear feedback shift register is used to generate PN sequence. So by the formula P equal to 2 power n minus 1, we can apply n equal to 4, that is 2 power 4 minus 1. So 16 minus 1, which is equal to 15. By using this circuit diagram, we can generate 15 PN sequences. After 15th, the 16th sequence again started from the first one. Here the input is given to X1. The output of the X3 and X4 shift register is given to modulo 2 adder, and the modulo 2 adder output is given as a feedback to the shift register X1. The output of the PN sequence is taken from the shift register X4. The initial stages of X1, X2, X3 and X4 can be any value but 0, 0, 0, 0 respectively. As said in the previous slide, the output sequence for 15 clock pulses is 000, 1, 00, 11, 01, 01, 111. After 15th clock pulses, the same sequence would again repeat. By using three properties, we can verify whether the output of the linear feedback shift register is a PN sequence or not. The three properties are balance property, run property and correlation property. First one, balance property. In the balance property, the number of output binary ones and the number of binary output zeros in a single period differs by at most 1. Here the total count of 1 is 8 and the total count of 0 in this sequence is 7. As said in the balance property, the output binary 1 is at most 1 when compared to binary output zeros. So the balance property is verified. Next, the run length property. A run length is defined as a continuous sequence of the same type of binary digit. A new run commences with the appearance of a different binary digit. The length of a run is the number of digits contained in a given run. In PN sequence, about half of the run are of length 1, about a quarter of the runs are of length 2, about an eighth of the run are of length 3 and so on. In this sequence, the first 000 is 1 run, the next one is 1 run, the next 2 zeros are run and the next 2 ones are next run likewise. Next, correlation property. Based on the correlation property, if any PN output sequence is compared with any cyclic shift of itself, the number of agreements differs from the number of disagreements by at most 1 count. Here The first sequence is the PN output sequence, and the next sequence is the cyclic shift of itself. In this, the first digit is varied as 0 to 1. The fourth digit varied from 1 to 0. Likewise, in this, the number of agreements differ from the number of disagreements by at most one count. The correlation property makes synchronization easier, since during synchronization, by correlating the transmitter PN sequence with the receiver PN sequence, the receiver PN sequence can be continuously delayed until a set threshold of the correlation under which acquisition can be declared is attained. The generated PN sequence is used in spread spectrum communication. The PN sequence is used to spread the input sequence. At transmitter side, the PN sequence is generated and spread among the input sequence, and at the receiver side, the same PN sequence generated at the transmitter side is used to despread the received sequence. Hence, we get the original message. For this, in spread spectrum communication, the PN sequence is used for spreading and despreading. Thank you.